Welcome to yet another lesson in Computer A Plus or PC repair and maintenance. Today, I want to focus on the motherboard and the connectors associated with the motherboard, and look at the hard drives interfaces used on PCs. Again, without any further delay, I'll go to my presentation. I plan to cover the following subtopics today: exploring the motherboard, exploring the computer memory, exploring the processor sockets, identifying the types of hard drives and hard drive connections, identifying the chipset, identifying a riser card or data card, exploring the CPU. I know that's a lot of work to cover, so we may have to continue this in the next lesson. So let's start. We did talk about computer memory. We said that computer memory is divided into two types. There is the main memory and there is the backing storage. The main memory I like to think of computer memory in this way. Okay. Computer memory is divided into two types. First of all, there is the main memory. And the backing storage. The main memory is the memory that is used when the computer is processing or working, performing calculations, doing normal operations. Backing storage is the memory that is used to store software and data that is not currently being used. Okay. The main memory is further divided into two types. there is RAM and ROM. Then backing storage is divided into a number of types, which we can group as follows, probably 3 types, broad types. The first one, we can say magnetic type of storage devices. The other one is optical, and the third one is solid state. Okay. So this in a nutshell is the summary of the computer memory. But most of the time when we talk about computer memory, we refer to the main memory and particularly the random access memory. Okay. The distinction here is that the main memory or primary storage is the memory that is used to store the data and the software that is being processed. Backing storage is used to store data and software that is not in use on a computer. So for example, you are typing a document in Microsoft Word. That software, Microsoft Word, will first be installed on a backing storage so that when you switch on your computer, you find the software. But when you need to use it, you double click on the icon to load it into the memory, which is random access memory. And once it's loaded, you can begin typing. What you're typing will primarily be stored temporarily in random access memory. Once you have finished typing or you want to discontinue typing, you might want to save that work with a file name to your hard drive. That is a backing storage device. Okay. Memory is, in this case, we're talking about main memory, is the hardware component of the computer, of the hardware component of the motherboard that works as a temporary storage space for the processor or workspace for the processor. In other words, as the processor is performing its functions of processing data, it will be accessing data and software that is already stored in the memory. The processor cannot work with software or data that is obtained directly from the backing storage. It has to be first stored into the main memory before it can be processed. So it acts as a workspace, and it's a temporal storage because the random access memory is said to be volatile. That is, it will only store data and software while power is supplied. So when power is turned off, the contents of RAM are lost, are removed. It does not return its data when you switch off the computer. So it is volatile. The data that is the contents of random access memory will only be stored as long as power is supplied. But the other part of the main memory is the read-only memory. Read-only memory is a non-volatile part. This is where the basic input and output system, software, or programs are stored. The programs that are used to start up a computer, to boot a computer. These are the programs when you switch on a computer that are going to perform some basic tests on your machine to check that the key hardware components are working normally. And then secondly, this software is going to start the process of loading the operating system. It's going to locate where the operating system is stored and load it into random access memory so that then the operating system is going to take over the control and coordination of activities on the computer. Because remember, when you switch on your computer, RAM is always empty. But once BIOS has loaded the operating system, the kernel, then it's going to remain in RAM until you shut down your computer. So RAM is volatile. It loses its content when power supply is removed. ROM is read-only memory. It will return its data even when power is turned off. And we did explain last time that ROM on modern PCs is a special type of, is stored in a special type of chip called CMOS, complementary metal oxide. This is able to return the content by means of a battery. There's a battery which continue to power it so that the information that is stored there about hardware, the basic information such as which hard drive contain the operating system, how many hard drives are connected to your system, what's the date, and so on, okay? And so when you notice that you switch on the PC and the settings are not what you expect, the most likely cause is the ROM is not working properly, and that is because maybe the CMOS battery is flat. The BIOS also performs an important function. it performs a post test, that is power on self-test. That is a test to check that the key hardware components are working, such as the display or the video card, the input, such as a keyboard, the processor, the memory, and when any of these components are not working properly, it will give an error code. Sometimes it will beep. Sometimes it will try to load the default settings so that you are at least able to see the message on the screen. Okay. The memory is built on printed circuit boards. The circuit boards are referred to as modules, that is, memory modules. And these are the ones which are fitted onto the motherboard in the memory slots. Computer memory is measured in megabytes or gigabytes. The common type of memory technology used on desktop and laptop computers is referred to as DIMM, Dual Inline Memory Module. That's for the desktop. And this is the big one. Then for laptops, there is small outline dual inline memory modules, or SODIMM. These are the small modules that you see at the bottom there. Okay, but we'll go into details at a later stage. But what I want you to appreciate is that these modules have contactors at the bottom, and they always have a key, a slot located somewhere. This slot is used to ensure that the modules are inserted in one way only, and secondly, that different versions or generations of memory modules are not interchanged because they are not backward compatible. A newer version of the memory module is not compatible with the previous generations. And so the position of this lock here is going to be different depending on which generation of module that you are working with. The same applies to the SODIMM. Okay. These contactors are different. The numbers tend to differ depending on the generation or version of memory module that you are dealing with. But in a nutshell, these are the ones which are used on desktops, and the small ones are used on laptops. Bus architecture. A bus is a connection. Normally, is a channel of communication that connects the memory and peripheral devices to the CPU. On the motherboard, we say that a motherboard is a printed circuit board. It consists of printed electronic circuits which have been printed on the surface of some kind of a board. Those are meant to allow the different components to connect with the central processing unit. Now, these are the ones which I refer to as buses. So a bus is a communication channel between the CPU and other parts of the computer system. Broadly speaking, there are two types of buses. There are internal buses, or which I refer to as system buses, that connects the processor, the memory, and other other devices. So there'll be for example, there's a memory bus which connects the memory to the processor. There will be a bus that connects the graphics card to the processor, and so on. There will be a bus that will connect other components to the processor as well. These are referred to as internal buses because these are the ones that you find printed directly onto the motherboard. But for the PC to be able to do its work, it will need a number of peripheral devices. And these devices will also have some form of buses which are going to connect these slow devices to the processor. On a typical motherboard, the peripheral devices are going to connect to a chipset, which in turn will connect to the processor. The examples of such are PCI slots, PCIX, AGP, PCIe, CRN. These are just some of the common buses that you expect to find on a typical computer system. PCI bus. PCI, that's the acronym for Peripheral Component Interconnect. This is designed to be used for a variety of devices that need to connect to the motherboard. And as you can see, there will be multiple of them on a given motherboard. Okay. They connect devices such that they appear like they're connecting directly to the processor, but they are not. They normally connect through a bridge because these tend to be slower than the speed at which the processor operates. The components connected using PCI bus slots are processor independent. In other words, they do not depend on the CPU, the design of the CPU. So you find that you can have a wide range of CPUs of different speeds, different architectures, but as long as they have this PCI bus slots, you are able to connect devices to them without thinking about what kind of processor is on that motherboard. So the PCI bus tends to make the peripheral devices to be processor independent. They don't depend on the processor. So it offers a layer of abstraction. Okay. The data transmission of used in PCI, the mode is parallel data transmission. Data is transmitted in parallel. These PCI buses, they offer data rates ranging from about 133 megabytes per second to about 533 megabytes per second. They can connect a wide range of devices such as network interface cards, sound cards, modems, etc., etc. So when you look at the back of a computer and you have a sound card, which is not built into the motherboard, that is most likely connected using a PCI. Or you may want, there are cases where the network interface card on the motherboard fails, it has stopped working. You can go to a shop and buy another one and come and fit it into the PCI so that you are able to connect to the network. Sometimes you want to provide additional sound capability on your machine. Again, the sound card can be connected via a PCI bus slot. Of course, this is an older technology which is being phased out. There are newer buses which have been developed, which offer better performance, and we'll be looking at them shortly. The AGP bus slot is another popular bus that you find on a typical desktop computer. AGP stands for Advanced Graphics Port. This provides the high bandwidth required by computer graphics. Typically, they are used to connect monitors or sound cards to be specific, video cards or graphics card to the motherboard. Remember, again, we did say that graphics card, they are those which are built into the motherboard, but there are also those which are added to the motherboard to offer better video and graphics features. Those graphics cards, they connect using AGP. It's one of the most common technology used to connect such video cards. And it has been around for a long time. It has gone through a number of revisions to make it, to improve the speed. The AGP card, a bus slot, offers a dedicated connection directly to the processor. I mentioned that the number of peripheral devices connect to a chipset, and then the chipset is the one which now connects to the processor. But for the AGP, it connects the graphics card directly to the processor. It uses parallel data transmission mode, and it offers data rates of in the range of 260 megabits per second to 2.1 gigabits per second. So it's extremely fast. Okay. And this is the one which appears orange here on top. Then there's the PCIe bus slots. This is a newer version of a bus slot which has been designed to offer better performance compared to the PCI and the AGP. These were developed to provide better performance in terms of speed and features. They provide higher data rates with a smaller size and less number of pin count. Pin count, that's the pin contacts that are found on the card or in the slot. So you can see in the diagram, I have, please take note, this is a mistake. The PCIe should be written with a small e, not capital E, okay? It comes in different versions. There are those which are very small, those are called PCIe 1X. But for things like video cards or graphics card and some other cards which require more speed, they are bigger, they are longer cards like this one, okay? They look very similar to the PCI. This is the PCI slot. It looks very, very similar, okay? So you have to pay attention to be able to distinguish them, to distinguish PCI and PCIe, okay? PCIe has further evolved to support hot plugging and hardware input and output virtualization. Hot plugging is a concept whereby a device can be connected to the computer or unplugged to the computer motherboard without powering it down. A typical hardware device, when you try to plug it into the motherboard slots without powering the machine down, will result in damage. But this PCIe as buses have been developed in such a way that you can do that safely without damaging your hardware. They also support hardware input and output virtualization. Virtualization, we're talking about the technology used to provide, for example, on a server, you can have multiple operating systems installed. And the operating system can connect to the PCIe devices and they'll be able to work well instead of relying on the host operating system. So the guest operating system is able to communicate with the PCI bus. The PCIe bus is different from the PCI. They are not compatible. The PCI uses parallel data transmission mode. The PCIe uses serial data transmission, but they can offer data speeds of as high as 16 gigabits per second on a 32-bit data bus. The buses can either be 32-bit or 64-bit, and in some cases they could be 16-bit. That's the size of the bus. Okay. AMR bus slot, that's audio modem riser. A riser is a special printed circuit board that can be inserted so that other expansions cards can be connected to it and via it to the motherboard. So it's going to be placed and it's going to appear perpendicular to the motherboard, okay, so that other expansion cards can be added, which are now going to be parallel to the motherboard. This was developed to enable implementation of specific input and output functionalities, namely audio and modem. So you could have a PC which doesn't have sound card, but the AMR can provide a means by which a card can be connected to provide those functionalities. Of course, it's an old technology, and that's what we have there. Okay. It can be used as an expansion card. And that's, you place the expansion card there. But you can also use it as a riser where, like I said, you place it in there and that printed circuit board will have now slots where you can now plug in other hardware devices. It is mounted directly onto the motherboard. It's very short and it's typically color-coded brown on the motherboard. CNR, that's communication and in networking riser, is like an improvement on the AMR riser, in the sense that this one, apart from offering the support for connection of audio and modem, it will also provide additional functionality which are not available in the previous bus. So this was developed to provide functionalities such as networking, especially on the low-profile motherboards. These functionalities were such as networking for network connections, audio, telephone. These were used on motherboards which did not normally have these built into them. They were able to provide these functionalities without necessarily requiring you to install other components. like for sound, networking, and so on. The communication and networking riser are both hardware and software controlled. What I mean is you can control them by using jumpers on the motherboard. Jumpers are like small switches which you can turn on and off to configure hardware devices. But others, you can also control them by using software. And like here, you may have noticed these AMR buses, they were not supporting controlling by software, and they were not also supporting plug and play. In other words, plug and play is when for a device to be recognized by the system, you have to shut down, connect it, usually with maybe screws, or you use some locking mechanism. Once it's in place, then you switch on, and that's when it is recognized. That's a traditional way. But plug and play is where immediately the computer is on, you connect the device, or the device is switched off, you connect this component. When you switch on, it's able to start working without requiring you to start performing some configurations. Okay, it's recognized by the operating system immediately, and you can use it. Okay. Now let me just distinguish between hot plugging or hot swapping and plug and play. Plug and play is a more general concept where the device connected is recognized and can be used immediately after it's available. Once your computer is switched on or once it's connected to your machine. But when we talk about hot plugging, it means you do not need to shut down the machine. Your machine can be working and you can connect this hardware device. It's generally not a very good idea, except for very special hardware components. And you have to make sure that those components are certified to be hot swappable and plug and play supported. PCMCIA is a technology that is designed for laptops. Okay, it stands for Personal Computer Memory Card International Association. This is an organization which designed an expansion slot, expansion technology to be used on laptops. The older laptops used to have very limited features. Some of them, they would have maybe either you can connect a floppy drive or CD drive. You have to change, you cannot have both of them. So, or they would have no network card. So the PCMCIA was developed as a standard to allow such additional functionalities to be made available on laptops. So this is a technology targeting laptops. So as you can see, this one is for the network interface card. So you plug this into a slot, and once it's plugged in, then you can connect this to the network cable. A PCI card implements PCMCIA card implements parallel mode for the connection, and they offer data rates of up to as high as 133 megabytes per second on a data bus width of 32 bits. This is a PCMCIA card for a network adapter. There were other types of adapters available. The next section is for us to be able to identify hard drives and drive connections. Computers need some sort of way of storing data for information to be stored on a long-term basis. Remember, we said that computer memory is divided into main memory, which is made up of RAM and ROM. These two are connected directly on the motherboard. And we said that particular RAM is used as a temporal storage during processing runtime. But when you need to have data which will be available for future use, you need to save it to a backing storage device. Not only that, main memory uses very expensive technology. So on any PC or computing device, the main memory tend to be very small compared to the backing storage. The backing storage uses cheaper technology, and so it is suitable for mass storage of data and software, which is not in use, of course, but they are very slow. The processor cannot directly use the software and the data which is on a backing storage device. So backing storage devices are typically used for long-term storage of data, as well as for mass storage. And the most common type of backing storage devices are hard drives, fixed hard drives, and portable or external hard drives. Now, we're talking about internal hard drives and how these can be connected. Okay, a computer can have more than one storage device. Can have a hard drive, a magnetic hard drive. It can have an optical drive. It can also have a solid state drive, like a flash disk. So on a typical PC, you can find even just the physical hard drives. You can have two or more of them on one PC. For laptops, because of space, most of them, they normally have one. But for the bigger laptops, especially those which are about 17-inch in size, they can have provision for 2 hard drives. Desktops can provide multiple connections for hard drives. And servers, that is special dedicated computers used on networks, can even have more provisions for connecting hard drives, because some of them are used for applications which require a lot of storage space, like a database management system. Okay, so a computer can have more than one storage device on it. The following have been developed as standards for interfacing, connecting hard drives with the motherboard. There's PATA, there's SATA, and eSATA. PATA is a name which was developed in retrospect. The name actually is, when it was developed, it was referred to as integrated drive electronics. Then after some improvement, it was listed as extended integrated drive electronics. The idea is, on these drives, there's a circuit board which is supposed to control the storage of data onto the platters which are inside the disk drive. The computer system, through the motherboard, will just communicate with the hard drive unit by sending the information to it. How that information is exactly stored is something that is controlled by electronics, which is built into the drive unit itself. These were called advanced technology attachment. But because recently a newer technology was found which used serial data transmission, these are referred to now as parallel ATA or PATA. So when we say PATA, we are referring to the IDEE or EIDE. Okay. Now, what makes it have that name? This is because the data transmission is in the form of parallel. The connector has 40 holes or pins there, but the cable itself, which is in form of a ribbon, has 80, some have 40, some have 80 wires in them. So there will be 2 per hole if there are 80. And these are used to connect onto the motherboard. And that one, it will have provision to connect maybe 1 or 2 hard drives on the same ribbon. Now, the pins are numbered from 1 up to 40. And you should not, because it's rectangular, it's possible to enter it in more than one way. So to prevent technicians from interchanging the connections, they have a cage, where there's an empty pin there, which is going to be corresponding to a blocked hole there, so that it can only go in one way. That is the orientation of the ribbon as you fit it in the connector into the slot. Also, the red, one edge of the ribbon is colored red as a way of indicating the side where there is cable number 1 or pin number 1. Okay, so you can ensure that you do not confuse the connection onto the motherboard or onto the hard drive. Okay, so this cable has this red line as a way of helping you to identify how it should be connected. Okay. Like I said, these PATA or parallel advanced technology attachment drives had provision to have 2 drives connected to 1 ribbon and 1 slot. Now, to make sure that all the 2 hard drives or hard drive and a CD-ROM drive or optical drive connected to the 1 ribbon are able to work without interfering with each other, one was designated as the master drive, and the other one was the slave drive. The way you do this is you could use jumpers on the hard drive to set it, to configure it to be a slave or to be a master drive. Also, you can connect the one which is connected in the middle will be treated as the slave. The one which will be connected on one other end will be treated as the master drive. Okay. What used to happen is for machines which use this type of technology, if you confuse the jumper settings on these hard drives, you'll find that maybe one drive will not be recognized or both of them are not going to be recognized. So what used to happen is when you see that you have connected 2 hard drives and they're not all being recognized on your machine, you needed to check the jumper settings. They would come with clear labeled positions to set them as master or slave or cable select. Cable select is like automatic, where the drive which is placed in the middle of the ribbon is the one which is going to act as a slave. The one which is connected on one end is going to be automatically configured as the master drive. The newer technology of connecting hard drives is SATA, Serial Advanced Technology Attachment. It was because of this name that the IDE was renamed as PATA, because it uses parallel. This one uses serial. This is an improvement over the PATA or IDE technology in a number of ways. One, the speeds for data transfer are much higher for SATA drives. they are more efficient. They offer more efficient data transfer. They use smaller and shorter cables. Also, SATA hard drives provides for hot plugging and hot swapping of drives. Like Kyle said, hot plugging is the ability of a hardware component to be connected while the computer is powered on without damaging it. Hot swapping is the ability of a drive to be deactivated and removed, and another one, similar component, connected in its place and activated. Like we do flash disks. When you are using a flash disk, you plug it in. When you no longer need it, you can use a feature to remove it safely. And you don't need to shut down the computer to remove a flash disk. In a similar way, SATA hard drives can safely be swapped while the machine is working. One of the things that you notice is that SATA drives uses serial data transmission mode, not parallel. That's why they are very small cables. The cables consist of 7 wires only, compared to the PATA, which has the 80 wires. Of course, they have to be connected only in one way, and they have a typical, well-known L-shaped connector. That means that you can't confuse the orientation of the cable. It can only go in one direction, okay? Both the one for data and the one for power. For power on SATA drives, they also have an L shape, but they differ in the number of wires. The one for power, although it looks bigger, it only has 5 wires compared to the data cable, which has 7, but it looks smaller. Okay. And the other feature is that for SATA drives, you can only connect one drive on one cable. They have no provision for configuring one to be master and the other one to be a slave. No, only one drive can connect on using one SATA cable. Please, this is important. This is the very important distinction in troubleshooting, and even just for job interviews. They can ask you questions about how you can configure a slave drive on a SATA cable. There is no such a thing as slave and master on SATA hard drives. The data speeds for SATA drives are in the range of about 1.5 gigabits per second to about 6.6 gigabits per second. SATA drives come in 3 generations. The first one had a speed of about 1.5 gigabits per second. With improvement in technology, that was doubled, and that was called SATA 2. SATA 3 is the current one that we're using, which has data speeds of around 6 gigabits per second. Now, if you compare that with the speeds that are offered by PATA, you can see that they are much, much faster. You're talking about 133. Some can go up to 233 megabytes. But SATA, we're talking about some going as far as 6 gigabytes per second. Of course, this is the theoretical speed. It tend to be lower because of a number of factors. But if the hard drive is SATA 3 and the cable and the slot is also a SATA 3, then you can theoretically achieve that kind of data speed. Okay, that's all I had prepared for today. I'll see you next time.